Hi, fifth graders. Today we're going to build off of what we already know about division and kind of refresh our memories on division where we have a decimal in our answer. So for this first problem, no need to write anything down. I just want you thinking. So I have two division problems here. One of them is 904 divided by 32, and the other is 456 divided by 16. I think this will make more sense if we think about this in a context. So for the first problem, let's pretend this is $904 that needs to be shared between 32 people. So everyone needs to get the same amount of money. This problem, let's think as $456 that needs to be shared between 16 people. So it's less money, but less people also to share with. So how do we know which group would get more money? So again, no need to write anything down. I'm going to solve. So in this first problem, I'm going to solve kind of quickly because this we should be pretty good at this point. Or getting better at. So 32 can't go into 9. 32 can go into 90 though. It goes in twice. And I did the work earlier. Two groups of 32 would be 32, 64. So that's what I'm subtracting. And 90 minus 64 is 26. I'm going to bring down my next number and repeat. 32 can go into 264. Again, I already did the math. I figured out it can go in 8 times. And 8 times 32 was 256. And when I subtracted, I got a remainder of 8. So what this is telling me, $904 divided by 32 people, everyone's going to get $28. The remainder, that $8, that's not enough to give those 32 people another dollar. So that $8 is just going to waste. It's just not going to be given out to anybody. For this problem over here, again, I'm going to kind of speed solve. 16 can't go into 4, but it can go into 45. In fact, it can go into it twice. I already counted it out. It'd be 16, 32. So when I subtracted, I got 13. So bring down the next number and repeat. Again, I already figured out 16 can go into 136 8 times. 8 times, which actually got me to 128. There we go. And then when I subtract, I got 8 again. And since there's nothing to bring down, I got my answer for this problem. So 904 divided by 32 was 28 remainder 8. And 456 divided by 16 was also 28 remainder 8. So everyone's getting $28, but there are $8 that are going to be left over that nobody gets. But that doesn't really make sense. If I want to divide, it wouldn't make sense having a remainder left over because what's going to happen to those $8? So in this kind of problem, this is when we would probably use a decimal as our answers. Before I go ahead and solve that way, I want you to look at these. These look like they are the same. It makes it look like 904 divided by 32 and 456 divided by 16. It looks like they're equal. Are they? Let's solve using a decimal this time to see, okay, if I broke up those dollars into change, how much change would everyone get? It's not enough for everyone to get another whole dollar, but they're going to get some change. So again, I'm going to speed solve. 904 divided by 32 and 456 divided by 16. So I already knew 32 can't go into 9, but 32 can go into 90. I said it went in twice, which was 64. and I got 26 when I subtracted, and I brought down the 4, and I said 32 goes into 264 8 times, which was 256, and when I subtracted, I got 8. I'm going to solve up to that point on this one as well. So it couldn't go into 4, but it could go into 45 2 times, which got me to 32. Subtracted and I got 13, brought down the 6. 16 can go into 136 8 times, 128, subtract, and I got 8. Okay, solved. So now they look the same, 28 with a remainder of 8. But remember, this time we're going to solve with a decimal. Do you remember how to do this? So I need to bring down, I just subtracted, so I'm going to bring down my next number. But wait, there is no number there. What do we do instead? We are going to add a decimal and a 0. There's no decimal in this number yet. So I need to add the decimal, then I'm going to have it add a 0. That'll be what I bring down. So my 8 is going to become an 80. Don't forget to bring the decimal up. On this side, I'm going to do that same thing. There's nothing to bring down, so I'm going to add a decimal and a 0 and bring down, so this 8 becomes an 80. Here is where they're going to be different. Their answers are not going to be the same. I'm going to tell you that now, because on this problem, we are now dividing again. I just brought down, so I'm repeating again. This time I need to divide 80, divide by 32. This problem, it's going to be 80 divided by 16. Are those going to get me the same answers? No. So on this one, how many times can 32 go into 80? It can go in twice. So I'm just double checking. Twice. Which would be 64. 2 times 32 is 64. Now when I subtract, 80 minus 64 is 16. If we're solving with decimals, I can't have a remainder. So I'm going to bring down another number. So that's 16 becomes 160. Repeat again. How many times can 32 go into 160? I solved earlier. I found it could go in 5 times. 5 times 32 was 160 exactly. So remember with decimals, the only time you stop is when you subtract and you get 0. When you subtract and you get 0 and there's nothing to bring down, you're done. So in this problem, instead of having 28 with $8 not given out, everyone's going to get $28.25. $28.25. Let's finish solving for this one. So now this time, remember, I'm not using my 32. Now it's 16. So it's going to be different. 16 can go into 80 more than 2 times. In fact, it can go in 5 times. 5 times 16 is exactly 80. So what this is telling me is the $456 divided by 16 people. Everyone is actually going to get $28.50. I'm just adding a 0. That's how we write money. 50 cents. So are these two problems equal to one another? No, they are not. Which of these is actually going to get us more money? This problem over here, $2 or $28.50 is more than $28.25. So although these problems look like they're the same, when you find their exact answer, our decimal answer, they are not, because one is dividing by 32 and one is dividing by 16. Okay, so that was a tough concept. I want you to do your best to explain that concept. So this is not the end of the lesson. We're actually going to work through problems like this, but I want you to check out your problem set. It's the lesson 26 problem set on page 297. Page 297. And I'm ignoring the bottom part. You are going to do some of those. But for right now, I want you to explain on 1A. So let's read it. It says 156 divided by 24. So this problem here, divide by 24. And 102 divided by 15. Both have a quotient of 6. So quotient is answer. And a remainder of 12. Are the division expressions equivalent to each other? Use your knowledge of decimal division to justify your answers. So I want you to explain why these may not be the same. And I'm even going to just show you, so if you want to write this down, the work in case that helps you. So 24 can't go into 1. 24 can't go into 15, but 24 can go into 156 6 times, which would get us to 144. When you subtract, you have 12 as your remainder. Over here, 15 can't go into 1, 15 can't go into 10, but 15 can go into 102 6 times, which would get you 90. And again, when you subtract, you get that remainder of 12. So the question, are these division expressions equivalent to each other? Use your knowledge of decimal division to justify your answer. So you don't even have to actually solve. I want you to explain with words, why won't these get the same decimals? When you're ready to check this problem, go on to the next slide.